Welcome, nutritionradio.org listeners. This is Lonnie Lowry, a university nutrition professor of over 20 years and podcast host of long-running shows like Iron Radio. Come on in. Market news from the food world. Hey, everybody. Today we have some food industry and food market news. We're going to look at the technology called CRISPR. Many of you may be familiar with this. A few episodes ago, we talked about how AI, artificial intelligence, is affecting food production, but so is CRISPR. So are some of these gene editing techniques. Now, CRISPR is not exactly the same thing as GMO, right, genetically modified organism, and it's looked at in a little bit different way depending on the country that you're in and that sort of thing. But what I want to touch on is partly based on a podcast that came out from the Institute of Food Technologists. For those of you who are interested, it's actually dated November 30th, 2021. So it's not brand new, but this is something that keeps coming up, and it will keep coming up in 2023 and beyond. It's episode 12 if you're interested here. It's called A CRISPR Food Future. And again, it's from the IFT's Side Dish podcast. This is what turned me on to it, but we're going to do a little bit of a deeper dive looking at some scientific literature as well. Here is the setup. It says, did you know it has been over 30 years since genetically modified crops were introduced for consumption? In this episode, guest Dr. Haven Baker joins us to talk about a relatively new form of gene editing technology called clustered, regularly interspaced, short palindromic repeats, or CRISPR. So that's what this episode is about. The host, Bruce Burkham, points out that yes, 30 years have passed since GM foods were commercially produced, and that the FDA says genetically modified foods, now this isn't exactly the same thing as CRISPR, but this is the setup, GMO foods are quote-unquote no different from a dietary perspective compared to non-GMO foods, and so they're regulated in a similar way. And that's true in North and South America and Japan. In Europe, they look at it a little bit differently, although I've been hearing some stuff that might change a little bit. So they don't need special labeling that they are, in fact, genetically modified. And again, we're going to talk about why this is different from CRISPR. Over 90% of soybeans, corn, and canola grown in the U.S. is GM. It's genetically modified. So if this freaks you out, you're probably already consuming a lot of these foods. And again, it's affecting agriculture and food production, often in good ways, and consumer acceptance we'll talk about in a little while. So who is the guest here? Haven Baker holds a PhD in chemistry from Northeastern University, an MBA from Harvard University, and a BS in biomedical engineering from Yale. So impressive background for this gentleman who is really taking science and moving it in the direction of business, of course. Here are some gold nuggets from the interview that was over half an hour long. The food product development life cycle is much shorter than the pharmaceutical one. Again, there's project managers, and they bring in people from different departments and aspects, and they all try to move toward, a first lot to stock, if you will. In my experience, this sort of thing in the food industry might be roughly a 2-year process, plus or minus maybe a year. It varies hugely based on the individual product, I suppose, but shorter than pharma. One of the appeals of CRISPR is that when the science comes in to these multidisciplinary teams, they can actually induce changes that might have taken 10, 20, even up to 50 years to do with traditional breeding techniques. And it can be very precise. It's not like GMO where they were inserting a foreign gene, sort of laying over top of the genes of a plant species. CRISPR is actually editing very precisely the existing blueprint, the native blueprint, if you will. The way that Dr. Baker explains CRISPR is that it's a GPS for DNA's 3 billion base pairs. So again, it finds the base pairs that need targeted, then the biochemists attach molecular machinery to repair /replace /edit base pairs to get the trait that they want. His company is, in fact, interested in seedless blackberries. 85% of consumers like the idea, and by modifying a very specific part of the DNA, right, with CRISPR, they can then have these seedless blackberries. There are some other types of things that can be done, of course, with CRISPR. This is just one of his company's foci. But he points out shelf life is a big deal, right? Blackberries, for example, don't have a shelf life beyond a couple of days typically, so that's problematic. You don't want food waste. Flavor and color variations across like these different types of berries, right? I mean, they took the genus Rubus, which has hundreds and hundreds of different species in it, 800 kinds of blackberries / raspberries alone, and they actually sequenced all of their genomes. So kind of a Herculean task going on behind the scenes. But I think the new focus, perhaps, of this interview was about consumer things that can be changed. Originally, yield was a big deal, right? Companies wanted return on their investment, so they wanted plants that were insect or herbicide resistant. And a lot of the attention was on grains because more acreage, right? More overall crops being produced, as opposed to, say, berries or something that's a little bit more of a niche that we're going to start to see companies look at moving forward. This can be good because most people don't eat enough fruits and vegetables. They were talking about people buying about half of what they should, or according to this interview, the USDA suggests that as little as 9% actually consuming what they should. So if you can make them last longer, taste better, be more appealing to consumers, fruits and veg could be a good target. Now, there was a side discussion about some concerns like, well, if you remove the seeds, how do you propagate the plant moving forward and that kind of thing? And they do consider these things. The truth is removing the seeds isn't as big a deal as I understand it when it comes to some of these plants because they're essentially grown from clones / cuttings. But the researcher that was being interviewed also pointed out that they can rescue the seeds at an early stage. They do think about these kinds of things when they do it. What they need, according to the interview, was better transparency with consumers. For example, what problem is the scientist trying to solve? Is this technology solving? One of the challenges with consumers was that on an individual level, they're interested in things that are very impactful on their family, like maybe getting their kids to eat more fruits and vegetables, and that may be because of less seeds or whatever it might be, different texture. I mean, they mentioned kale, for example. It's not as appealing in many ways as some other foods. It's part of the brassica family, like, broccoli, for example. But it's kind of tough and chewy, and it has some sort of pungent and even mustardy notes. And if they can change some of those things and make it a little more appealing, there'll be more consumption. So things that hit the family matter. People are concerned about global issues and that sort of thing and the ecosystem, but the focus in this interview was really about things that impact the family. And that may be the kind of thing that could be a pro or con for you. Obviously, to a businessman, things that are more appealing sell more. They want that to happen. Yes, there's even concerns on the scientific side. There's discussions about will this gene editing technique, again, it's only really been driving since about 2012 and forward, but will it reduce variety in the edible biodiversity, that kind of thing? The interviewee says no. I mean, you're going to see things like blackberries that might be more appealing outside of their usual use, like in jam, again, because of shelf life issues or seediness or whatever. Other grains may start to become more popular because they can make them more appealing. Sorghum, millet, and wheat were examples. I know there's a lot of wheat out there already. But probably, there are catch-up grains, I think is the point. So everything isn't just all corn all the time. There's a lot of that going on in the U.S. They are concerned about off-target effects when it comes to when they make this change. Could there be accidental damage to other base pairs in the DNA of the plant? So they do look at a lot of this kind of stuff. And they're even bringing in specifically like marketers and consumer scientists to help steer the biochemist, the scientist, toward what consumers actually want. Again, with the idea of transparency. If people know what's going on, they're going to be less frightened, probably. Now, we're almost out of time, but if we just take a quick look at a paper, this is from Shew, S-H-E-W, and colleague. This is a 2018 paper, CRISPR versus GMOs, Public Acceptance and Evaluation. So just to kind of give you a straight from the literature look here, it says CRISPR gene editing has major implications for agriculture and food security, but not many studies have actually looked at the acceptance from consumers, and that's what they did here. It says in the USA, Canada, Belgium, France, and Australia, 56%, again, that's USA, 47% for Canada, 46% for Belgium, 30% for France, and 51% of respondents from Australia indicated they would consume both genetically modified and CRISPR food. So it really depends on the country. Again, if you're in the U.S., here is 56% for the U.S. Look at the Canadians, though, 47%, quite a bit less. But we're talking about generally a third to a half of people indicate that they would consume these types of foods. And again, a lot of this has to do, I think, with public education. The researchers in the Aaron Shu paper, which was Global Food Security, was the journal, December 2018. They set it up like this. CRISPR is being heralded as a promising technology because it can accurately insert and alter DNA with targeted specificity and relatively easy implementation. Hence, it has the potential to be pivotal innovation in the drive to feed the current and growing world populations. We struggle to feed the current population of 7 billion people globally due to a myriad of challenges, including yield gaps, post-harvest losses, market access, nutritional diversity. It says beyond these problems, population growth and climate change will obviously, create challenges, and the scientists are looking for ways to make plants that are both more robust and for consumers more acceptable, like from a sensory, right, from a hedonic perspective. However, many consumers have reacted negatively to previous agricultural applications that were derived from biotechnology. Again, this is from the Shu paper, namely GMOs, particularly in the European Union. The EU really kind of had this stricter, more negative, if you will, view of this as far as I've understood it. It says, yet CRISPR gene editing can differ markedly from the genetic modification technologies introduced in the 80s and 90s, again, the GMO kinds of stuff. Specifically, and this reinforces what we heard in the interview, CRISPR could be used to introduce changes to DNA intrinsic to the target species or cultivar, whereas traditional genetic modification introduces foreign DNA from a different species. So again, it's less alien, if you will, to the target species. So what do you think about CRISPR and this more precise kind of genetic modification, gene editing? Is it weird? Do things that hit home matter more? Or are you glad that they're actually looking at things like color, flavor, texture, acceptability, and it's not just about crop yield, super high crop yields? You could let me know on YouTube. You could search for Lawnman07 or nutritionradio.org. You can leave a comment or even a review on iTunes. We are now on iTunes. And let me know. So that's going to be it for this time. We'll see you later.
The nutritionradio.org podcast is for informational purposes only. If you're interested in starting a diet or exercise program, check with your physician, nutritionist, or qualified exercise physiologist in order to make the progress that you need.